grade 12 learners. Welcome to today's physical science lesson. Today we'll be revising. Our revision will be on physics, physical sciences paper 1, which you are writing tomorrow. We're hoping that you will get marks and you will be able to move and you will have understanding. So the main aim of this lesson is to ensure that you are ready for paper 1. You are going to collect marks. You are going to be able to answer all the questions that are going to be asked on the paper. And if you check the topics for paper 1, as we usually always say, you have written prelim, now you know the structure of the paper. To say we have 65 marks that comes from mechanics. We have 15 marks, which is your wave, sound, and light. That is your Doppler effect. You have 55 marks that comes from electricity and magnetism. You'll remember you are having your electrostatics, you are having your current electricity, you are having your electrodynamics. Now, you have your 15 marks for matter and material, which is your last question, which is your photoelectric effect. So those are the questions that you do. It would be nice that these questions with 15 marks, you are able at least to collect that 30 marks, because that will be a good thing to do. Remember, 30 out of 150, that will be about 20% of the paper. So it's important that sections like wave, sound, and light, which are easy to collect marks, you collect as many marks as possible. Questions like photoelectric effect, you collect as many marks as possible. However, for this lesson, we're going to go through all these topics. So we're going to move. And then we are saying the total is 150 marks. You'll be sitting for 3 hours. And we are saying the weighting level 1 questions is 15 marks. You have your comprehension, your understanding, and then you have your analysis with 40, and your evaluation questions, which is 10% of the paper. So that is what you are expecting when you write your paper 1. It's still 10 multiple choice questions, which is 20 marks. And you are saying structured questions, you'll get 180 marks. The total is 150 for 3 hours, as I indicated. Now, if we look at the structure of multiple choice questions that were written last year in November 2023, we had question 1, which is 10 questions, 2 marks each. And we are saying on the multiple choice questions, answer all the questions. Don't leave any question unanswered. And if you look at the structure, we had Newton's laws of motion in 1.1 and 1.2. We had VPM, or vertical projectile motion, in multiple choice question 1.3. We had momentum 1.4. We had work, energy, and power 1.5. We had Doppler effect in 1.6, 1.7. We had electrostatics. And then 1.8, we had the electric circuits. And then 1.9, we have electrodynamics. And 1.10, we had photoelectric effect. It's important when you're answering multiple choice questions to know which section or which topic the question is coming from, because when you answer, you'll be able to respond correctly. Now, we are saying the structure of today's lesson is in this way. We'll look at the content for the whole topic. We'll summarize it and move forward. Remember, the main thing here, problem solving strategies. How do you go about answering questions? We can't leave definitions out. Remember, we are saying for all the questions that you are going to write, you are going to find questions that says define. So we are saying if there are 9 definitions, questions, please get all the 18 marks, and then you know that you are able to move. So this is the first mark that you ensure that as far as definitions are concerned, you're going to collect your marks. And we are saying problem solving in terms of your multiple choice questions and structured questions. And then the topics, as indicated, we're studying with Newton's laws of motion. Remember, we're doing the Newton's first law, second law, third law, and Newton's law for universal gravitation, vertical projectile motion, momentum, work, energy, and power, Doppler effect, electrostatics, electricity, electrodynamics, and photoelectric effect. So that is how the topics are arranged for this particular lesson. I'm hoping that you have a pen and paper and a calculator. You'll be able to do that. You have your data sheet close to you. Remember, a data sheet is something that you will always keep close to you, so that you are able at all times, you are able to go to the data sheet and be able to choose the correct formula. Remember, if you choose the correct formula, you must be able to substitute on that particular formula. If you just copy the formula from the data sheet without substituting on it, you won't get that 1 mark of the formula. Please ensure that you dress your formula. Now, In terms of Newton's first law, we are saying there are three things there that we must think of. Is that the object is at rest. An object will remain at rest, not moving. And then we are saying, or the object is moving at constant velocity, or we are saying the forces are balanced. When the forces are balanced, we know that the object won't be moving. So hence we say Newton's first law is F net equals to 0. So when you're stating it, you will say it to say, okay, an object will remain at rest. That's why F net is 0. An object will remain at rest or in constant velocity. Constant velocity simply means final velocity is equals to initial velocity. So if you look at the acceleration there, it will be 0 because Vf equals to Vi. So that is constant velocity, meaning the velocity is not changing, or when the forces are balanced. So you got to know Newton's first law. We're saying an object will remain at rest or in constant velocity unless acted upon by an external resultant force. Now, Newton's second law, we are saying now F net is no longer equals to 0, is F net equals to MA. It's there in the data sheet. So if you have forgotten, just go there. Then the main thing here, you are saying when the net force is applied on the object, remember the object has mass M. When a net force is applied on the object will accelerate in the direction of the net force. So that's what we are saying. We're saying when a net force is applied on the object will accelerate in the direction of the net force. However, you get your marks when you start to say acceleration is directly proportional to the net force and acceleration is inversely proportional to the mass. You write that in weights and you are able to get your 2 marks. Please ensure that all the questions that say state Newton's laws, you are able to collect those marks. Now, Newton's third law, we are saying when body A exerts a force on body B will exert an equal but opposite force on body A. So you are able to do that as well and get your 2 marks. And then we are saying these Newton's laws, you will always remember them. Now, in terms of the problem solving strategy, how do you go about solving problems that involves Newton's laws 1, 2, and 3? We are saying in application of Newton's laws, the following are important. The main thing there, free body diagram or force diagram. I think by now you know the difference between free body diagram and force diagram. For free body, we usually just make a dot and we are able to draw our forces. However, we make a box there when we are drawing our force diagram and we are able to indicate all those forces. So it's very much important. The next thing which is very much important is this surface, whether the surface is rough or smooth, because immediately when we say rough surface, we are saying we have friction. And then when we say the surface is smooth, we are saying frictionless. There is no friction. And we are saying pay careful attention to the mark allocation. For questions involving calculations, just routine calculations, you just have to identify the formula, you substitute, and you get the answer, and that is your 3 marks. Hence, we've always been emphasizing that here in paper 1 more especially, we talk to formula, substitution, you get your answer with correct SI unit and direction. If it's a vector, we don't want you to lose marks by not indicating the direction. As long as you're dealing with vectors, you will definitely have to indicate in which direction. But when you're dealing with scalar quantity, it has only magnitude but no direction, so you don't have to show the direction. In fact, in terms of the marks, we're saying when you have 4 marks or more, you'll find that this might be a multi-step type of question. So those are things that you must always remember when you're dealing with questions like this one. Now, let's move now straight to the questions. As I indicated, the main thing here, we're going to do the strategy as to how are you going to respond to question. Last year, 1.1 November 2023, a question was asked, a constant net force is applied to a block. Which one of the following statement is correct? It's very much important before you answer a question to ask your question yourself which law, because I'm dealing with Newton's here, which law talks about a constant net force. When a net force is applied on the object, what will the object do? Because it's applied to on an object. So you're able to see that here we're saying, okay, when a net force is applied to the object must be able to accelerate in the direction of the net force. Now, which one of the following statement is correct? The block will move with a constant velocity. constant acceleration, constantly increasing acceleration, and constant decreasing acceleration, then you are able to see that we said, remember we said acceleration is directly proportional to the net force. So we have constant net force, we have constant acceleration. Then you are able to choose your answer there as B. Now for 1.2, we are saying a crate of mass M is stationary. Remember, the main thing when you see an object like that in an incline is to first see the forces that are acting on that particular object. You got to understand that we always have a force that is straight here, which is your Fg. But because this Fg is certain angle, we are going to resolve it into components. Remember, when you're drawing the free body of force diagram, you don't have to resolve your forces. So your responsibility is to make a dot and indicate that, okay, there must be this Fg, because it's a certain angle, we are saying that it must be having two components, which is the Fg perpendicular, which is moving in that direction, and the Fg parallel there. So you are able to see that, okay, we're having Fg parallel, that is pulling the object downwards. And then because the object is stationary, it means there must be another force that is opposing the movement of this object. And that will be your frictional force, which is now opposing the movement of that particular object. Hence, it's remaining stationary, which means we have balanced forces. So you're able to see that we have balanced forces. And which one of the following statements regarding the magnitude of the frictional force acting on the crate is correct? The magnitude of the frictional force acting on the crate is equal to the component of weight to the crate, which is parallel to the plane, or is larger than the component of weight which is parallel to the plane. So the main thing that we know that the forces that we're talking about are the forces that are parallel, because these are the two that are opposing forces that are when we look at how the object is supposed to move. Now you can be able to see that it's not the perpendicular forces that makes the object moves in this direction. So it must be A or B. But now for the object not to move, it means the two components, the Fg parallel and the friction, they are equal. So you are able to see that the correct answer must be saying it is equal to the component of the weight of the crate, which is parallel to the plane. So you are able to do that with no problem, and then you are able to choose your correct answer. Now, we are given now a scenario there to say a 5 kg block resting on a rough horizontal plane. Please ensure that you are highlighting that rough, because now you are saying this is a rough surface. It tells you that we have friction. So don't forget that it's connected to a 12 block by a light inextensible string that passes over a light frictionless pulley. A 5 Newton force. So we're having a 5 Newton force, which is our applied force there, to the 5 kg block at 80 degrees to the horizontal as shown in the diagram below. I think now already you start to remember that the question can be a state Newton second law, and then or the question can be draw free body diagram. In this case, the question said draw free body diagram showing all the forces acting on the 5 kg. Please underline that 5 kg. You don't want to make a mistake of drawing forces acting on the 12 kg block while the question is talking about the 5 kg block. So it's important that always you know that which block are you talking about. Now, on the 5 kg, please don't resolve no forces. What you do, you will draw, it's a free body, so it's a no body diagram. You just make that dot, draw the forces as they appear on the object there to say, okay, we are having our tension that is moving there to the right, and we are having now our applied force of 5 Newton that is going upward like that. That is our applied force. We are having our normal force that is always perpendicular to the surface, and we are having Fg that is always going down. But remember, they said that this is a rough surface, so don't forget that. They said that this is a rough surface, so we must be having friction that is opposing motion like that when the object is moving. So you are able to know now how your object are going to, your free body diagram is going to look like, and how you're going to get your 5 marks. And the next question was the coefficient of kinetic friction between the 5 kg block and the surface is 0.2. Immediately when you see that 0.2, you will know that when do we use the coefficient of kinetic friction. You know that that is when we calculate our normal force. So when we calculate our normal force, we can be able to do that. Hence, we have the question that says calculate the normal force acting on the 5 kg block. Now, here is very much important for you now to think about how we are going to resolve our forces. Remember, we have a force at an angle there. That's why it's not the same. When the force is at, for example, when you are having an object in a horizontal plane, your normal force will just be straightforward. You'll just be the same as mg. But in this case, your normal force is not equal to weight because you are having another component that is acting upward as well, which means now your weight is equal to the normal force plus the component, which is the vertical component, that is equals to weight. So you are able to know that now, because we are at an angle, our normal force will include the component now, which is our Fy, which is our F sine theta, which will be our F sine 30, because our theta is given as 30 there. So it's very much important that you have that, and then you are able to say, okay, normal force would be the difference between mg. Remember, our weight is mg, so it will be mg minus 5, which is our force, sine 30. And then we are able to go to the calculation without wasting time to say you will have the component, the normal force plus the component equals to weight, and we are saying this is 30 degrees. So you are able now to calculate to say, okay, if we say our 5 and that 9,8, we are able to get our normal force of 46,5 newtons. And the next question was the question on calculate the kinetic friction. For kinetic friction, we are saying, don't forget, this formula is in your data sheet. You will get that 1 mark for the formula. You will get the 1 mark for substituting the coefficient of kinetic friction, and 1 mark for and the last mark for getting the correct answer with the correct SI unit. Then you are able now to say we are getting our 3 marks here for calculating the kinetic friction. I hope that helps you. When you go to our last question, which is 2.4, which says calculate acceleration of the 5 kg block. It's very much important here. That's when we're saying apply Newton's second law, because Newton's second law, we are saying F net equals to ma. So when we're saying F net equals to ma, what are we saying here? We are saying, okay, add all the forces that are acting there. They must be equal to ma. And if we check when we were drawing our force diagram, we're able to say, okay, how many forces that we are having there in terms of the 5 kg block. So you are able to see that, okay, we are having 5 Newton that is being applied. We are having the frictional force. We are having the tension. The main thing there is the sign to say the direction where the tension is going and the direction where the friction and our Fx, our horizontal component in terms of this force, are going. They are in opposite direction. You will see as we do the solution, we are going to say F net equals to ma, but we are saying the friction and Fa and our applied force, the component of the applied force, are in opposite direction. Hence, when you add the forces to get F net, you will say T plus, you indicate that the friction is in the opposite direction and the horizontal component is in the opposite direction. Hence, you write them as negative, and you are able to substitute them. You'll get your 5a when you take your friction that side, which was 9,3, and your 5 cos 30, which is your Fax. You're able to get that, and then that is your equation number 1. So that becomes your equation number 1. We're bringing back maths here. Remember, you have been dealing with simultaneous equation. Remember, you have two unknowns here. You have t and 5a. So you can't solve that problem because you have two unknowns. So you must go to body number 2, which is the 12 kg block. In the 12 kg block, you have seen it was hanging like that, the 12 kg block, which means we had our tension, which was in the opposite direction, and we have our weight, which was going downwards. So it's important that even if we didn't ask you to draw the free body diagram for the other object, you are able to draw it because you'll be able to determine the two forces. So you can see that our F net now for this one. So you are applying F net equals to ma on the second block, and then you are saying that will be weight positive, and then t in the opposite direction, hence it's negative. But you still show that you are adding them because this is a net. Net means you are adding together. And then you are able to say the mass was 12. Then you are able to say mg minus t equals to 12a. And then you are able to substitute your mass, which was 12, and your g, which is 9,8. And then you make t subject of the formula. Because all of them, they are equal to 2, it means 1 is equal to 2. So you can equate this equation to that equation. And after that, only maths is done. It's left, the science is finished. All you have to do now is to apply your maths. You put this part on the left, the other part on the right. And then you are able now to have one unknown, which is a. And then when you take the 12a, that side becomes 17. 17a becomes positive. Then you divide by 17 both sides. Then you are able to get your answer of 6,12 meters per second squared. I am hoping here that you will ensure that you don't do the body system thing. You just apply Newton's second law for body A and apply Newton's second law for body B separately. Then you get your two equations. You now simultaneously solve your equation until you find our acceleration, which is what we did on this question. Without any wasting of time, we'll be moving to the next section, which is your vertical projectile motion. As I indicated, here we are showing you how to collect the marks. So for question 2, we're saying the free body diagram. You have your marks there. For writing F net equals to ma, you had your marks. Be able to add all those forces that are acting on the object, and then we have shown you the importance of plus and minus, because the direction will tell you that the other ones are going in the opposite direction. Then you are able to subtract the ones that are opposing the motion of an object. Now, under vertical projectile motion, here we have two important definitions that you must know. It's a definition of a projectile. So we're saying, please, when it comes to the definitions, don't lose no mark. Collect these marks. We're saying now, a projectile is an object which has been given an initial velocity. So we're not wasting time. We're saying when it's an object that has been given initial velocity, and then it moves under the influence of gravitational force only. So you can see that the second part, which is now the motion under the influence of gravitational force only, is what we refer to as free fall. So which means your projectile, the moment it leaves the thrower's hand, your projectile now undergoes free fall. So you are able to see that these definitions, they are almost the same, but the difference is that for a projectile, it must first be given an initial velocity. So we're saying a projectile is an object which has been given an initial velocity, and then it moves under the influence of gravitational force only. Now, what is free fall? It is just motion. It's a motion during which the only force acting on an object is the gravitational force. So you can see that we are saying this last part of projectile is what we are saying when it comes to a free fall. So please, we are saying these are the two most important definitions for this section. Know them and be able to collect your marks. Now, you must know how to use the equations of motion to determine the position, the velocity, and displacement of a projectile. You must know how to sketch the velocity versus time graph. We're saying, please, any question that says sketch a graph, position versus time graph, velocity versus time graph, acceleration versus time, please, you can't leave exam without responding to a question that says draw these types of graph. You will have seen that when you're dealing with your position versus time graph, you will definitely just draw what is happening. If a ball is thrown up, then it comes back to the thrower's hand, you just draw it like that. Then if it passes, then you draw that it passes like that, and you are able to show that here with time in seconds. So that's when you're saying upward is positive. So you are able to draw whatever is happening, you just draw as it happens, and that gives you a position versus time graph. However, when it comes to velocity time graph, we're now dealing with our straight lines, which are not horizontal. So we're saying, okay, it has initial velocity, okay, it reaches maximum height, and then it goes and passes. So if it passes, you can see that the motion when the object was going down, it took longer. Hence, your line won't be the same, because if it passes the thrower's hand, you'll have a longer line after maximum height. And you are able to say, this is my velocity in meters per second versus time graph. Please be able to collect those marks. The same with your acceleration versus time graph, which will be a positive like that. And then if you were changing the direction, then it's able to move like that. And you are able to label your axis to say acceleration is in meters per second squared and time is in seconds. Please collect those marks of drawing the graphs. The main thing is to dress these graphs with the values that you will have calculated. If there is time to reach the maximum height, time to do what, you are able to now substitute those values there, and then you are able to get your marks in terms of the graphs. Please don't lose marks pertaining to that. The objects, free-falling object, the issue of an object thrown vertical upwards, an object thrown vertical downwards, and bouncing balls, the bouncing objects. So we only do the bouncing balls, and then we are saying if you for a given graph, you must be able to determine the position, displacement, and velocity or acceleration. So we'll give some of the questions. Tomorrow you are expecting either you will get a graph or you will get information. Then you will be asked either to draw a graph if the question comes, or you will be given a graph, then you will answer questions based on that. So please, those two scenarios is the things that as you are preparing now for your paper, you ensure that I am able to answer questions if I'm given information, and then I'm able to read and do data collection and choose the formula and do calculation and draw the graph. Or I will be given a graph, then I will utilize that graph information in order for me to answer the question. I think you get that, and you will be able to do that. Now, we are saying now vertical projectile motion, as we indicated, the two definitions very much important. What is a projectile? What is free fall? Those ones, they must be in your pocket. As if they are there in the paper, you are able to get that. But I want to emphasize here the importance of the data sheet. This data sheet is your friend. You must move with it. But data sheet is nothing without data collection. We are saying collect information, and the information that you have collected is the one that will tell you which formula will be able to help you to answer the question. Please ensure that you don't choose the formula. You don't have favorites here to say, this is my favorite formula, I will always use it. No, you collect data, and data will tell you which formula you're going to utilize to answer the question. So those are your 4 equations of motion under vertical projectile motion that you will be expected to do. Now, we always say on the strategy of VPM to say draw the trajectory. It's better to draw to answer questions of something that you can see. So we are saying you draw the trajectory and you put critical points in your trajectory. What are the critical points? We are saying the point of launch. For example, at A here, you're on top of a building. So that is the point of launch. So when the object is going up, you know it has initial velocity, and at B there, it reaches maximum height. Those are small things, but we're expecting that you don't do mistake. You always draw your trajectory, and you make sure that you look for the point of launch, the maximum height, which is our B there, the point symmetrical to the point of launch, which is C. That point is important because we are saying there, the velocity now at A is equals to the velocity at C. What is different is the direction which the object is going. And then we are saying the time it takes from A to B is the same time from B to C. So for you, if we say calculate the velocity at G, you know that that velocity will be more than initial velocity, because as we pass the point C, the velocity is now increasing until it reaches G, which is our maximum velocity just before it rests at the ground. Now, we're saying choose the sign convention. It's very much important to say upward is positive or downward is positive. We can't stop to emphasize that, because that's where learners lose marks if now you are just putting everything as positive. Remember, when the object is going up, you got to tell us that upward is positive, then we'll know that G, which is going downward, will be negative. So it's important that you do that. And we are saying, don't forget the points of symmetry. I've talked about it. Or we'll talk about the time symmetry to say at C, the time is the same as A from A to B or from B to C. And then the velocity symmetry at C, the velocity is equals to the velocity at A, because now the difference is the direction. The constant magnitude and direction of G. We're saying G, or gravitational acceleration, is always downwards and is 9.8 meters per second squared. Please, if they're saying what is the magnitude and direction of acceleration, you know gravitational acceleration is 9.8 meters per second squared downwards. Always consider motion between any 2 points. Please, instead of solving the whole scenario, just let's solve issues small, A, B, B, C, C, G. Then it becomes easier for you to do that. and we are still emphasizing the FSAUD to say you will after you have collected data, because the data will tell you which formula is correct, you will write the correct formula, you will substitute on that formula, you will write the answer, and your answer must go with the what? Correct SI unit. And if you are dealing with a vector, you will talk to the issue of direction. Please, let's not lose marks on those small mistakes of not utilizing that. A stone is thrown vertically upwards and returns to the thrower's hand after a while. Which one of the following position versus time graph best represent the motion of the stone? So you are able to see that, okay, if the thrower was there, he throws the object up, it comes back to the thrower's hand. So it's supposed to have traveled same distance in terms of that one, so that it doesn't help us. But now you are able now to see that, okay, this one not necessarily looking like a position versus time graph. Remember, they are mostly our caps, and then we are having this one. You can see that the thrower is throwing from there, reaches maximum height, comes back to the thrower's hand at C. So you're able to choose C with no doubt. Now 1.4, a person dives from a high platform into a pool. At which one of the position A, B, C, or D will the magnitude of its momentum be maximum? The main thing we want to show here, remember the trajectory that that this person is undergoing. This person is diving from a high platform into a pool. So that's the motion. So you know that from D to maximum height C, velocity was decreasing. Now, when we come back to the where the person dived from, we are saying the velocity is equal. Remember, we talked about time symmetry and velocity symmetry. So you're able to see that, okay, the velocity now is equal there. At B, the velocity is increasing. At A, just before he hits the water, the velocity is maximum. And the question is about what? Momentum. And you know that momentum is defined as the product of mass of an object and velocity. So you are able to see that that question now will say P equals mv. The V is maximum, which means we have maximum momentum at A, because it depends on the velocity. So you are able to say the position where we have maximum momentum is position A, and that is number A. So you are able to get your 2 marks. Hence, I said when I started that you are not going to leave no multiple choice unanswered. We must be able to see A, B, C, D. No matter how unsure you are, you will put something there. You can't leave the space. You will put something because you have 25% chances of getting that correct answer. So please don't leave multiple choice unanswered. Now, with no wasting of time, we look at a structured question. This one was based on the graph. As I indicated, the main aim of this is for you to have the strategy. If you have a graph like that, that's saying a ball is thrown vertically downwards, immediately when you say thrown, you know we're talking about a projectile. And we said a projectile from the top of the building and bounces a few times as it hits the ground. The velocity time graph below describes the motion of the ball from the time it's thrown to a certain time t. Take downwards as the positive direction and the ground as the zero reference. The graph is not drawn to scale. The effects of air friction are ignored. So that is very much important. Then you are able to see that, okay, it was having now, it was thrown vertically downwards. Hence, you see that it started with initial velocity of 10. As it's going down, its velocity is increasing until it reaches now 29.6. Then it bounces. When it bounces, and then it spends 0.2 seconds there on the ground, because that's the type of the questions they might ask you, or to say how long did it take for it to reach the maximum your maximum height there, which is your 2 seconds. So it's important that you have all that information and you know what happened before or after the bouncing. With no wasting of time, let's go to questions. Write down the speed with which the ball is thrown downwards. So you just there, you know that is the initial velocity. The initial velocity is the velocity at time 0, t equals to 0. So you are able to say initial velocity was, you can't say 10 when you're talking about speed. You must say 10 meters per second. SI units are important, so we emphasizing to yourself, show that it's 10 meters per second. Now, all parts of the graph have the same gradient. Give a reason for this particular reason. for these particular questions. So it's very much important for you to start now to ask what will be the gradient. What will be the gradient under velocity time graph? Remember, gradient is changing y over changing time. Don't forget that. Changing y is changing velocity over changing time. So you know changing velocity over changing time, that must be acceleration. You remember we said g is constant. Gravitational acceleration is constant. It remains 9.8 meters per second. Hence, we are saying the gradient of the velocity time graph is equal to the acceleration of the object. And the acceleration is what? Is constant and equal to the acceleration due to gravity, which is our 9.8 meters per second. I hope you get that and you are able to move. And I hope we are moving together. Now, let's go to calculation type of questions. Saying calculate the height from which the ball is thrown. Calculate now the height from which the ball is thrown, because this whoever was throwing the object was on top of a particular building. Now, the importance now of this is that you must be able now to say what is the data that I'm having, the data that you can be able to collect. You can see that our initial velocity we had there was 10 meters per second. Our final velocity was 29.6. Our acceleration 9.8 meters per second squared. So all that information is very, very important, because as and when you come to this data collection, you are able to show that, okay, I had initial velocity of 10, and then the velocity there was 29.6, acceleration was 9.8, change in y is what we're looking for, and then change in time, it took 2 seconds to reach there. So you're able to collect all that information. When you choose the formula, you know that the correct formula must be having change in y, because we're looking for change in y. That makes this to be disqualified. And then you are able, when you go to the second one there, change in y via delta t, you are looking for change in y, you are having initial velocity, you are having time, you are having acceleration and time. So you are able now to use that formula and get. And you can use any other formula that will help you to solve that question, and you are able to determine the height of the building, which was 39.6, and then the time t shown on the graph as well. You are able to calculate the final time there. Remember, for t, you know already that we had time there, which was 8 seconds, and we want the time that we dealt with there. And then you are able to know that the final velocity there, because here on the graph that will be 0, and then you are able now to do your calculation. Initial velocity was minus 25, and then you know the acceleration, and then you can determine your time. And with no wasting time, you're able to determine 2.455 as your time. You add the 8 plus 2.55, because the question was the time from there to there, which is 8 plus the 2.55 for that motion. Then you are able to get 10.55. I hope you will do as many questions as you can based on the graph. To say, write down the time the ball is in contact with the first bounce. After the first bounce, there we said it's 0.2 seconds, because it's between 2 and 2.2. And then it was write down the time at which the ball reaches its maximum after the first bounce, and then we were able to say that was your 2.2 seconds. Is the collision of the ball with the ground elastic or inelastic? So that question is important, because we are saying now, is our kinetic energy remaining the same? So you can see that as the ball spends some time on the floor, you can see that there is change in velocity. So you can see that it is not elastic. Why? Because kinetic energy is not conserved. Remember, we are saying that for elastic, kinetic energy must be conserved. Now, with no wasting of time, we're able to move to our linear momentum and impulse. Now, again, we're going to emphasize the importance of definitions in terms of this one, to say our momentum is a vector, and momentum from the data sheet, P equals to mv small p. And then you know that we are saying it is the product of mass of an object and its velocity. It is the product of mass of an object and its velocity. That is the 2 marks you're expecting if they say define momentum. And we're saying momentum is a vector, which means it has got both magnitude and direction. And we're saying any object that is moving has momentum, and the symbol for momentum is small letter p. Units of measurement of momentum. Remember, mass is in kilograms and velocity is in meters per second. Hence, momentum is measured in kilograms meters per second. And because velocity is a vector, that's what makes momentum a vector. And we're saying momentum is P equals mv, where P is the momentum in kilograms meters per second, m is the mass in kilograms, and v is the velocity in meters per second. Don't forget the m for the mass there is a small letter m as well. Linear momentum, we said, is a vector, and we talked to that one. Now, let's go to tips. How do you answer this type of question? Read the scenario carefully. Hence, everything that we are doing is about reading carefully and underlining the keywords and be able to do what we refer to as data collection. And we're saying, remember the velocity, the momentum, change in momentum, and the average force. They are all vectors. And if they are all vectors, we always have to talk about their direction. So if the question is saying calculate the velocity, be careful. The question can say calculate the speed, which is a scalar quantity. So when you say speed, we're saying don't show the direction. But when you say velocity, we're talking about now a vector quantity. Momentum is a vector, change in momentum is a vector, and average force is a vector. So all of those you will take into consideration the direction. And we're saying always refer to the data sheet when carrying out calculations. But I'm saying you don't go to the data sheet empty-handed. You go with data that you have collected to say which formula is going to help me in order for me to answer my question. And we are saying pay more attention to the mark allocation. A routine question, we talked about it, is an easy 3 marks question. Elasticity of collisions, we talked about that. To say the total kinetic energy before collision, when is equals the total kinetic energy after collision, we say the collision is elastic. But for inelastic, the total kinetic energy before is not equals the total kinetic energy after. So if we say define elastic collision, you are saying kinetic energy, both kinetic energy and momentum are conserved. In elastic collision, we are saying only momentum is conserved, but the kinetic energy is not conserved. Please don't make mistakes of forgetting those things. Now, not necessarily here the main aim is for you to remember how to go about doing these calculations. Now we are saying a wooden trolley of mass 2 kg moves to the left with a constant velocity of 3 meters per second. And we are saying a bullet of mass 0.03 kg is fired horizontally from the left towards the trolley.